Okay, everybody. So today's video on populations, sampling distributions, and kind of calculations that we need to do um, may or may not be a good place for you to start with this. I made a video yesterday that was just about the concepts, what a population is versus what a sample is, what we do with a sample, and so on. Okay. So if you're having trouble following this one, then you might look at the other one. It's posted previously in the list of videos, okay, for the assignment. Um, but probably this is an okay place to start. All right, I'll do a little bit of explaining of the concepts, but not as much as in the original video I posted on this topic. But anyway, okay. So the concepts are that we have a population, which has a mean and a standard deviation. Okay. What's the mean tell us? It tells us where the numbers are. Okay. And the standard deviation tells us how spread out they are. Okay. So roughly that's what they tell you. And then we take a sample of a certain predetermined size from the population. Okay. And then we calculate the mean of the sample, the average. The mean is the average, okay? All right, now, what can we say about the mean of the sample? Then it will have its own distribution, okay? With the mean being the same as the mean for the population, and the standard deviation being the standard deviation for the population divided by the square root of the sample size. Okay, that's also called the standard error of the mean. Now, let me put all this in the context of an example, all right? So you'll run into an example a lot like this on my math lab. It says the heights of fully grown trees of a specific species are normally distributed with a mean of 77.5 feet and a standard deviation of 7.25 feet. Okay, so what's that mean when it says like for the population, the heights of the trees are normally distributed? It's like gives us a way to do calculations. Like I can tell you like most of the trees have a height within one standard deviation of the mean. So like most trees of this particular kind are going to be between 77.5 minus 7.25 feet or 77.5 plus 7.25 feet. Okay, that's sort of like in very rough terms what it means to say the heights of trees are normally distributed. Okay, now we take a sample from that population, and the population's like every tree that we can get our hands of this kind. The sample is just 20 of them in this case. So we take a random sample of size 20 drawn from the population, and then we find the mean height of that sample. So it's like we take this sample of size 20 and we find the average height of those 20 trees. Now, what can you say about that average height though? I mean, that's a number. You're going to take 20 trees, find the average height of those 20 trees, and you're going to get a number. What can you say about that number? That number is normally distributed, okay? And it has its own average and its own standard deviation, all right? So the population, the heights of trees in the population, those numbers have their mean and their standard deviation. And if we take a sample of 20 trees and we find the average height of those 20, then that number has its own distribution with a mean and a standard deviation. Okay, so all right, I mean the population has a mean and a standard deviation. You take a sample of size n, you find the average of those numbers, and then that number has a mean and a standard deviation. Okay, so those are all the layers. Okay, I know I can just tell you how to do the math, but I guess that's not as fulfilling for me, and I don't think it's as good for you, all right? Anyway, so let's try an example. So this one is very straightforward, to the point. Okay, it says there's a population. It has a mean mu, that's the Greek letter mu, of 151 and a standard deviation sigma of 27, Greek letter sigma. Find the mean and standard deviation of the sampling distribution of sample means with a sample of size 54. Well, it's like, that's what, this is. This is the sampling distribution, all right? So what did it say? It says the mean of the sampling distribution is the same as the population mean. So that would just be 151. That's what it said, right? And then the standard deviation of the sampling distribution is sigma, the standard deviation of the population, divided by the square root of the sample size. Okay, so that's 27, and the sample size was 54, so it's 27 over square root of 54, which if we do some rounding by a calculator, we get 3.67. Okay, so there, and that is a case of just applying those formulas the way they are. Okay, now let's try another one. Let's go back to this problem with the tree heights. So I think I've already explained this quite a bit already, but it says the heights of fully grown trees of a certain kind are normally distributed. Mean is 77.5, standard deviation 7.25. Okay, that tells me what I can expect from the heights of these trees, that they're going to be within 7 feet of 77.5 feet or so, okay? And then the samples of size 20 are drawn from the population, and we find the average tree height of those 20. All right, now what can we say about that? It says calculate the mean and standard error of the sampling distribution. Okay, well, so about like says what can you say about this number? The average height of these 20 trees. Its distribution will have a mean the same as the population mean, 77.5 feet, and a standard deviation, also called a standard error, of the population standard deviation of 7.25 feet over the square root of the sample size, which is 20, so that's 1.62 feet. So I could say that when you take this sample of size 20, and you find the average height of those 20 trees, then it's going to be within, most likely, 1.62 feet of 77 feet. That's what it says, okay? But that's what it means when it says that that's the sampling distribution. All right, now to put more details to it, the sampling distribution will in fact be a normal distribution, all right? So we can use our normal curve and our calculator in StatCrunch to do the math for us in a very precise way. So what I can expect from this average tree height of a sample of 20 trees is for it to look like this, okay? All right, has a mean of 77.5 and a standard deviation of 1.62, and most of the values are going to be in here. See, that's like the biggest part of the curve. The area under the curve represents the probability of those numbers on the horizontal axis, or the likelihood that a random number from that distribution is going to fall in there between, looks like 76 and 79 or so, something like that. Most of the numbers are going to be like that. Okay, all right, so that's what the distribution looks like. And if we need to do calculations, it will be with a normal distribution with mean 77.5, standard deviation 1.62. Okay, now to our question. What is the probability that a random sample of 20 trees has a mean less than 76 feet? Okay, so that's asking about this, right? This right here, this distribution, that's what it's asking about. Like, I find 20 trees, I find the average height. What are the odds that that's going to be less than 76 feet? Well, let's go to StatCrunch and calculate those odds, okay? And that shouldn't be too hard because I know it has a mean of 77.5 and a standard deviation 1.62. So let's do calculators and then we go to normal. Okay, so I'm dealing with the normal distribution, 77.5 feet for the mean. Standard deviation, 1.62. And I want to know what the probability was that the number I get was going to be less than 76. So I say here, there's my mean and standard deviation. This is probability that X, my number, in this case the average height of 20 trees, is less than 76 feet. Compute. Not very likely. I got, looks like 17.7% chance. Okay. 0.177. All right. Well, that's my answer. So let's do this. I'll write it this way. We could say probability, well, okay, 0.177, or depending on how you want to express it, 17.7% chance. Okay. Now, I would think that if you were reading this question on my math lab, or however you're doing your homework, and it would say the sampling distribution and calculate the standard error of the mean, and it'd be a lot of new terms that make it sound like we're in far deep into new territory. But what it just comes down to knowing that you're dealing with a normal distribution, knowing the formula to calculate the standard deviation, and then going to StatCrunch for your number. Just like we did when we started working with the normal distribution.